Hello and welcome to Chapter 8 Bivariate Correlational Research. This is part 1 of 2 parts for Chapter 8, and the reason for that is the length of this particular chapter's lecture is a little longer than our systems can easily handle, so breaking it into 2 parts works better. By the term bivariate, that's similar to bicycle, meaning 2 wheels. Bivariate means 2 variables. And what we're doing is research that is based upon making at least 2 measurements and making association claims based upon 2 measurements. For instance, an association claim might be something like short height is related to depression in men in the military. Now, this is a simple association claim. There's no attempt to make a statement that height somehow causes depression or that depression causes height differences in people. Merely that this is an association that is observed and it may be fruitful for exploring other areas and avenues. Similarly, long-term anxiety is related to increased heart attack risk. In this case, it's clear to see that we can't know for sure if anxiety is causing heart attack risk or if persons might have some awareness of issues with their heart, which leads to them having anxiety over a long term. Furthermore, there could be a third variable entirely. And we're going to explore all these issues in a lot of detail because making sure you really understand the nature of a correlational statement, a simple association statement, and the limits of that statement is vital to good understanding of the benefits and limits of research methodologies. I want to remind you a little bit about validities that we consider to be important. The general concept of internal validity is the extent to which we can conclude that antecedent conditions, the manipulated conditions in a study, cause the measured outcomes that we might see in a study. External validity is the extent to which we can say what we find in our study can apply to other people and other situations. And we want to be always cognizant of these validities. Now, manipulation is our key to getting high internal validity. We have to have control over conditions and other extraneous variables that might be potential influencers of the dependent variable that we're measuring. We want to get control over those things so that we're only left with the manipulation that we intend to cause differences in conditions. We also have to use random assignment, and that creates the opportunity for us to no longer be concerned about differences from individual to individual being an influence over the outcomes in the study. But the fact of the matter is it's often impractical or impossible, unethical, or very costly to make changes in conditions or to do random assignment. The manipulation is just not something we can do. Because of that, we have numerous non-experimental methods, and we've been doing some work on that already. We did some surveys. We learned about surveys as a non-experimental design, and we discussed that in previous chapters. Correlational designs is another non-experimental method that allows us to learn something about the nature of the world. In a correlational design, we're not doing any kind of manipulation of conditions. We're not assigning people randomly conditions. We're taking people as we come. We're making observations as we can see them. And therefore we lose internal validity. We're not able to make any kind of causal statement from correlational research. That doesn't mean it's not useful. It's very useful. We can gain often greater external validity because we're often making our observations in more natural environments and situations instead of creating the kind of control you need in a laboratory setting where we can keep the condition manipulations only to exactly what we want them to be and eliminate extraneous variables. There's an artificiality that comes with that that means that external validity is reduced almost always. Therefore, we rely on correlational research often to give us a greater sense of external validity. What a correlational research is a research design that's characterized by simply observing 2 or more aspects of each observed object. Now, most of the time we're talking about people in psychology research, but it doesn't have to be people only. It can be events, and we observe 2 or more aspects of the event, 2 or more aspects of a place. For instance, we could do research on people's houses, and we could look at the house's external appearance, and we could look at the price of the house, and we could make some kinds of do correlational analysis on a rating of appearance with its price to see if that has there's a relationship there. We could be looking at trees, observing the amount of shade cast by a tree and the degree of temperature reduction. We could look at classrooms as a unit of analysis, the number of students in the class and the level of quality of instruction that is able to be attained in the class. We can look at the level of school, could be the observed object. A therapy session could be an observed object. Children and so forth. Any number of things can be the object we observe about which we record two or more aspects. So I'm going to give a few examples of some of these aspects of these objects with two or more aspects observed, and the kind of research question we might be interested in asking in those situations. For instance, we might be observing college students, and we could observe the time they spent doing online exercises and their course grade, with a research goal of determining is the time spent on a course associated with the grade earned. We could look at Olympic medal winners with and note their podium position, gold, silver, bronze, and see what their nonverbal displays of happiness is. Is podium position of medal winners associated with the degree of happiness displayed? And it turns out that it is associated with that. It turns out that the gold medal winner and the bronze medal winners show much more happiness than the silver medal winner, which may be a little counterintuitive, but do some reading on this. It's actually very interesting stuff. Neighborhoods. So we're going to observe neighborhoods. We're going to measure two things about them. We're going to measure the walkability of the neighborhood, and then we're going to measure somehow the proportion of people in that neighborhood who are obese. We may do that by an observational method. We may do that by some kind of survey of the people in the neighborhood. And we're interested in, are obesity rates lower in neighborhoods that have greater walkability? Is there an association? Therapy sessions. Number of tissues used from a box, and therapist rating of client's progress in a session. This is a completely fanciful kind of association to be talking about, is a client's emotional involvement represented by tissue use related to therapist rating of progress. But nevertheless, we're noting a object of observation, the therapy session, and the two things that we might be able to measure from it. Always remember, there's no random assignment conditions done, and we have practicalities and ethic issues to deal with, so that we can't do random assignment, but we can do possibly careful observation. So the key limitation of the correlational research approach: causation cannot be inferred, even if a very strong correlation is found. For instance, is student-to-teacher ratio associated with better test scores? And let's suppose it looks like this scatter plot. This is not real data. This is fake data. But each of those crosses in the scatter plot represents a student who scored what we call a mean grade equivalent score on a reading test, and they're all fifth graders. And also what the student-to-teacher ratio of the school that student is attending. Now, what we're imagining is we've somehow sampled 37 students across some wide span of space, that each of which are at different schools that have different student-to-teacher ratios, and each of these students therefore also scores their own individual score on this reading test. Fifth graders can score very high, meaning they're a fifth grader, but they're reading, in the case of a student, might be reading as high as 6.8th grade, almost 7th grade level. And other students might be reading as low as the 4th grade level. It could even be farther afield than even that, but that's what is represented in the graph. And what we see there is a fairly strong relationship, that the higher the student-to-teacher ratio, there it is, that is, the more students that are being served by each individual teacher, therefore less individualized attention, presumably, the lower the test scores for students are. And so we think we're seeing a relationship, and there's an implication of causation that teacher to student ratio might be causing students to do worse. As the student to teacher ratio goes up, then the students' reading scores go down. But there's all kinds of other ways these two variables might be associated with each other. What we're seeing is just the simple observation. The student to teacher ratio is related to grade equivalent score. We've seen only that relationship. Now, we kind of expect, we believe that the causation is student to teacher ratio causing grade equivalent scores. But believe it or not, it's plausible that grade equivalent scores causes student to teacher ratio. Now, you might be saying, well, that's just kind of bizarre, Bernhardt. How in the world can you imagine that? Well, it turns out that if you imagine a school that's having a great deal of success, that they may have a lot of helpers volunteer to come in and do more, because people like to be associated with success. And so they see a school doing well and they say, hey, we're going to volunteer up there because that's cool. We get to be associated with the success of the school. And because the notion of who is a teacher in a school is actually kind of poorly defined. You may think it's very easy to define, but who is? How do you count a student aide? Are they a teacher in the room? Or are they, just a volunteer that doesn't count as a teacher? What about parent volunteers that help in the school? Are they a teacher in the school? Or are they simply a volunteer that shouldn't be counted as a teacher? Well, you don't have to think long and hard to realize that an awful lot of these volunteers are students, even if they're getting paid as assistant teachers, are doing a lot of teaching work. Should they be counted or not is obviously key to the construct validity of that measure. And as you can see, if the construct validity of that measure gives us an insight into the possibility that this relatively unlikely but still plausible correlation of grade equivalent scores causing student to teacher ratio to go up is there. A third variable causation could be simply there's a wealthy district where people are able to spend more money, therefore reducing student to teacher ratios and yielding greater grade equivalent scores. So we cannot make any kind of causation statement from simply finding a relationship, an association, a correlation. It's simple fact that there's too many possible alternative explanations for what we've observed. These other influences or paths of connection could exist between the variables, so we can't make a clear statement of a causal path. The reason that we have experimental methods is to eliminate these alternative explanations. So why do causal research if we can't get to our ultimate goal of some kind of causal statement about the relationship between variables? Well, ethics is one of the things, as we've mentioned. It's sometimes unethical to manipulate some things. I mean, suppose we believe low amounts of sleep could increase the injury rate of infants in a family, that if the parents are getting less of sleep, that infants could be injured. Well, experimental manipulation of sleep could be dangerous for the infants. In fact, it could be dangerous for the parents. And so if our hypothesis is true, we're basically saying, well, we're going to put your child and your family at risk. The ethics of that are obviously very bad. And so you just can't do that kind of thing. You can't go around manipulating ethics in that kind of way, or manipulating sleep in that kind of way for ethical reasons. So we're going to do and so we have to do correlational observation of people. That's not unethical. We can ask them about their sleep. We can even make more direct observations about their sleep in certain situations, and then make observations about how they manage their kids, treat their kids, and possibly other measurements to get a sense of injury rates of the kids. Also, it's practical. Some things are impossible or irrational to manipulate, but we can observe it. Do males and females suffer from greater sleep deficits? Would narcissists use more first-person pronouns than non-narcissists? In the first case, I can't manipulate persons to be male or female. Regardless of relatively recent advances in sex reassignment surgery, we still know that we don't have persons that are male and female in a kind of, in a heteronormative sense, therefore having all the background that comes with that. And we can't therefore use that kind of reassignment to therefore use for judgments on this kind of thing. Furthermore, it's just unethical to do it in any kind of randomized fashion, so you're never going to get what you think you're going to get from that kind of study. It's just kind of irrational and impossible to imagine being able to do anything that manipulates the sex of a person or the gender of a person. Similarly, I can't assign persons to be narcissistic or not. They either are narcissistic or they're not narcissistic. That's just the way they come. And so we are left with a very simple recognition that all I can do is get a handle on whether or not there's an association between a person's personality style of narcissism and their use of first-person pronouns. Furthermore, we can get at external validity, sometimes referred to as ecological validity, can be improved. It's easier to do in the field compared to experiments, and therefore observing events and behavior in the natural environment gives us an obvious benefit. I mean, it's possible to do true experiments in the field conditions, but it's just very, very difficult compared to the lab. And so we get the benefit of higher external validity and therefore often better predictions of actual behaviors of persons. We also want to have a few moments about the scatter plot, which is kind of our standard way of representing the graphical association between one variable and the other. Each of the x's in this graph represents an individual student who was measured about their student-to-teacher ratio and their reading test score, their grade equivalent score. In this case, you're looking at a relatively strong negative correlation. Now, there can be perfect representations between variables, what we would call a perfect correlation. This would be a perfect positive correlation with everything moving in lockstep upward. Each incremental increase in student-to-teacher ratio gives an incremental increase in mean equivalent score. This is obviously an implausible outcome, but it is representing a perfect positive correlation. Similarly, there can be a perfect negative correlation. That is, each lockstep increase in student-to-teacher ratio gives a similar lockstep decrease in grade equivalent score. Perfect positive correlations and perfect negative correlations are representing the same degree of relationship. The positive and negative just tells you whether or not the slope is upward to the right or downward to the right. And there's all kinds of ways to have no relationship, where the correlation is represented by the letter R. For correlation is the symbol we use as R, is 0. And so it can be a flat line, it can be a scattering around a horizontal line, a vertical line, or it can just be a blob of points. Most often, we're working in the world of in between. We're dealing with correlations that are between 0 and plus or minus 1. We can't ever have a correlation greater than 1, by the way, because that indicates perfect relationship, and anything better than perfect simply doesn't exist. So some degree of relationship between variables is what we're usually observing. A strong negative linear relationship would look like this: a tight, tight, tight spiral looking a lot like a cigar or cigarette. Sloping upward to the right, it would look like that, a strong positive linear relationship. More often we see things that are moderately strong. This is actually a pretty strong one in the world of this kind of thing, but nevertheless strong positive, moderate positive linear relationship. Sometimes we have categorical variables. These things resemble true experiments because you have a categorical variable, which is often how we have things set up in experiments, is to create two categories or more categories by our experimental manipulations. And because of the fact that they have an appearance, a face resemblance to true experiments, they're called quasi or quasi experiments. But they lack the manipulation of conditions. They lack random assignment of participants. Therefore, the interpretation is exactly the same as correlational designs. Causality can't be inferred. We have low internal validity. Let me describe a little more about what we mean by this resemblance to true experiments. In a true experiment, participants are randomly assigned to conditions. So we imagine that we have participants of two different types to keep it simple for discussion purposes. So in the random assignment, a green type person and a pink type person goes there and there and there and there. And we have the persons relatively randomly assigned to their conditions, and we don't have any concerns about there being differences that are systematic between the two groups. The conditions of the study have all of each group in them, etc., etc. The random assignment helps us out. Now, in a quasi-experiment, we also have the two, well, they're not really conditions, they're two things. But the participants are the conditions that are based upon that characteristic, this green, pink, or purple representation. And so persons end up in their two conditions based upon that feature. So it looks like an experiment. We have these two categories of people, two categories of situations, so to speak, but in fact they're there because of characteristics of the person. This is why it looks like an experiment, but it's not an experiment. When you go to graphing these kinds of studies, if we were to do something that looks like a scatter plot, it would look something like this. And so this is males and females, a hypothetical set of data that is showing that females have a greater attention span than males. And as you can see, it's quite simply a graph where each individual dot is representing an individual's score on attention span and their male or female status. It's the same thing as a scatter plot, except it doesn't look the same because the data is not literally scattered all across. It's in these two columns. We can often do a similar kind of graph that's just, instead of taking all the data points, simply calculates the average of the males and the average of the females, and just have a couple of bars that are at those heights, and use those as our graph to show the difference between males and females on attention span. Both are appropriate ways of graphing the data, and depending upon what kind of information you're trying to communicate about the data, one or the other may be preferred. So, we've learned about how we go about thinking about correlations, building a correlational study. Those are important things to think about. Now we got to get into interrogating the association claim. How can we trust it? How can we evaluate it? How can we have some confidence in what we're seeing there? Fundamentally, all studies have questions evaluated about measurement. We have to determine the construct validity of the measures. Now, your book goes into a great deal of detail about this, and we have studied construct validity on numerous occasions previous to this. I'm going to leave that to you. I'm not going to lecture on construct validity because we have talked about it, and it's pretty much all the same things being said again here in the context of two variables, not just one variable. We also need to evaluate the statistical validity, and that's going to be in part 2 of Chapter 8's presentation. I look forward to seeing you there. Thank you. Bye.